My name's Yash. I'm going to be talking about OpenTelemetry and gRPC, more specifically about how we've instrumented gRPC with OpenTelemetry. Some details about me: I've been working on gRPC since 2017, so I've been here for quite some time. The observability effort in the team started, well, there was an open census implementation a few years back, which is now deprecated. There's a history over there. That plugin support still exists and still works. But since it's deprecated, we're now moving to OpenTelemetry, which is the new, wild, popular thing. So at the very basics, what's OpenTelemetry? It's an observability framework to collect and manage telemetry data. But why do we want observability? Why is this such a popular topic right now? So just taking a step back, assuming we've got, let's say, a deployment of services. Well, actually, before I get too deep, can I get a sense of who all of you are already familiar with gRPC, OpenTelemetry? Are you familiar with gRPC? Have you worked with it in the past?
Yeah.
Have you used OpenTelemetry?
Yes.
Nice. But you're the only person other than the gRPC maintainers. Right. So please feel free to stop me at any moment, ask any question that you want. You might not be the only person who has those questions. Right. So why do we want observability? So assuming we've got some kind of deployment, some kind of system, some kind of, let's say, a service mesh deployed somewhere. We often get questions in mind like, is my system actually working? Is it doing the thing that's intended to do? And if we feel that something is wrong, what do we look at? How do we figure out what's wrong? Another common scenario is trying to improve system performance. We know that our system has has some amount of QPS, right? But how do we figure out why is it that QPS? Why is my request taking so long, right? Observability can help you answer some of these questions. And alerting, we cannot expect a human to constantly look at dashboards. So we want some kind of alerting behavior to tell us when something is wrong. Those are just few scenarios that you might want to use observability in. And there are tons of solutions for observability. So if you just Google around as to how do I instrument my code or how do I observe my system, you see tons of solutions. So why do we use OpenTelemetry? What's special about this? So the main key problem that OpenTelemetry tries to solve is trying to avoid vendor lock-in, right? So let's say we have Google, and Google proposes some observability solution that's specific for Google workloads. And you have your workloads running on Google Cloud, things are nice, but let's say you choose to take your workload somewhere else, right? You don't want to end up changing your code too much just to continue using observability. You don't want that to be a roadblock. That's where libraries like OpenTelemetry come in, where the idea is you have the standard protocol, a set of semantic conventions, and this very common API across its language implementations to just use, figure out, and get observability. How this works at the vendor side of things is vendors would have an exporter, right? So let's say we are using Prometheus. Prometheus is a very popular exporter. Prometheus would have an exporter written in the OpenTelemetry library, and you can configure your application to say, I want to use OpenTelemetry and export my metrics using Prometheus, right? And that takes away some of the dependency on what you're using to record your metrics and observe them. Few more benefits: it's free and open source. There's nothing stopping you from using it. And it's extensible. It's kind of like an advanced use case. OpenTelemetry covers kind of built in a manner that you can inject it you can add your own injections and hooks at various points. So for example, if you really don't like the exporters that OpenTelemetry provides by default. You can write your own. Same for trace propagators. You can also write your own OpenTelemetry collectors, and I'll get to that a bit later on as to what exactly that means. But the idea is you don't want to be locked in with a particular vendor. Just a brief history. This idea of having a standard solution that works for observability without having vendor lock-in, that was not something that OpenTelemetry tried to solve the first, right? You had OpenCensus and OpenTracing also trying to solve the exact same problem. But the decision was to kind of combine these two projects, OpenCensus and OpenTracing, and come up with a single project, OpenTelemetry, that kind of takes the best of both worlds. So both of these projects are now deprecated, and OpenTelemetry, as I said, is the new popular thing, which is supported by many popular companies and products. You have Jaeger, Grafana, AWS, Azure, Datadog, Google Cloud, Splunk. And you've got implementations in most of the popular languages. Let me know if you work in any language that's not over here. All right. So jumping a bit into OpenTelemetry and the signals that it provides. So the three signals that we get from OpenTelemetry are traces, logging, and metrics. This slide shows tracing. So at a very general point of perspective, what we want to get from tracing is you have a request. You want to figure out what happens during the life of a request. So let's say you have a client that makes a request to the server, and the server, again, makes a request to some other backend services. So a trace would allow you to see what's happening, at what point does my client make the request, how much time it's taken to reach the server, what is the server doing, how many requests is the server making. And each individual work item is configured as a span in the trace. And the overall trace shows up as a tree of such spans. Then we have logging. It's very self-explanatory. It's super popular. Logs have been used since, I don't know, time immemorial to debug stuff. Printf debugging. Then we have metrics. And this is something that I'm going to dive a bit more into. This image is taken from OpenTelemetry. But my goal for this presentation is to show gRPC's instrumentation of, how gRPC is instrumented with OpenTelemetry. But before I do that, I kind of want to give some briefers as to what OpenTelemetry Metrics look like, how to actually use it, what the API looks like, so that the example doesn't seem too foreign. So at the very start, the architecture of OpenTelemetry is kind of layered into two parts. One is an API, one is an SDK. API is just a set of interfaces. It's not really implementation. If you just use the API and try to record metrics, it'll be a no-op. You won't see any metrics. SDK is where the actual implementation comes in. So the idea is if you are a library author, and for us, that's gRPC, gRPC would be using the OpenTelemetry API to actually record metrics, right? But if we just use that and say, gRPC record metrics for me, nothing would work. You would actually need to plug in an OpenTelemetry SDK into the gRPC OpenTelemetry plugin to make things work. I think the original idea behind why this separation is, let's say you have an OpenTelemetry SDK implementation, but for some reason you don't like it. You have the power to go in and write your own SDK. I doubt anyone would, but as I said earlier, OpenTelemetry was meant to be very extensible so that people can try to do anything that they want. Right. going a bit into the APIs, and this is just so that the later examples and demo doesn't seem too foreign. I'll try to not be too boring over here, but meter provider is the entry point of the API. This is where you configure your exporter. This is where you tell OpenTelemetry, this is how I want the metrics to be exported to this backend. This is also where gRPC would come in. gRPC would take the meter provider, create a meter out of it, and that kind of says, this is the scope of my metrics. And from that meter, it tries to create instruments, like counters, histograms, gauges. In instruments, you have synchronous and asynchronous. And that's, as the name suggests, asynchronous, that's you register a callback with OpenTelemetry, and OpenTelemetry would ask you for the current state of the system, as opposed to synchronous, where whenever events happen, you tell OpenTelemetry as to whenever those events happen.
Or like it's like analogous to MVC. Based on that.
I'm not sure what you mean.
Okay.
Sure. Finally, some code. So this example shows you, and I'm using C++. Sorry if you use Java or Python. It's pretty similar. But at least the idea is similar. So over here, what we're trying to do is we're trying to create a meter provider and configure it with a Prometheus exporter. Pretty straightforward, nothing out of the ordinary. Let me know if you have any questions. And this is where gRPC comes in. You'll see gRPC will take the meter provider, create a meter, and then it would create instruments. So let's say we want to create an instrument that captures the duration of an RPC. So you would create a double histogram, and whenever an RPC ends, or rather when we know the duration of an RPC, we would use that instrument to record the duration, along with attributes. Attributes are usually they're key value pairs. So let's say for an RPC, what's important? You get the target, you get the method name, you get the status of the RPC. So when you're actually observing the results of the metrics, you can kind of filter RPCs based on what the status was, see what the error rate was, what the QPS is. And I'll kind of show examples during the demo on this. Coming to gRPC instrumentation. So as I said earlier, we have a gRPC open census solution, and that has both metrics and tracing implemented. But as I said, open census is deprecated, and people are moving to OpenTelemetry. We don't really want to get stuck with an old deprecated solution, especially when the whole world is moving to OpenTelemetry. But for gRPC team, we cannot easily just break open census support. We need to keep supporting open census while we develop OpenTelemetry. So internally, what we ended up doing is we created a layer of indirection. That's how we solve all computer science problems, and it works. So we have this internal metrics architecture, which is stats plugin agnostic. Irrespective of whether you take open census, OpenTelemetry, it will collect metrics in the right manner. And while we're doing this, we kind of took open census metrics that were already existing with gRPC, and we looked at them. We figured out there are some ambiguities, some annoyances that we want to fix. And we removed those, came up with OpenTelemetry's set of metrics. And we're still developing more metrics. So if there are certain features that you would be interested in, please let us know. We'll consider adding them. As part of this effort, an interesting side benefit that came up was we can now register multiple stats plugins on gRPC. So earlier you could just have open census, but now you can have both open census and OpenTelemetry at the same time. And this mainly helps for transition. You don't want to just lose your open census observability while you're moving to OpenTelemetry. So you'll probably be in a state of transition where you see both metrics at the same point. And then eventually, when you're convinced the OpenTelemetry metrics are good enough, that's when you'll finally move. You can also register multiple OpenTelemetry plugins. And this is something that came up as an important use case for us. And the idea was there is some channels that want to be exporting metrics to certain backends, but some other channels want to be exporting the backends somehow differently. So this is something that is not supported by our current architecture. So win-win across the board. Coming to how you would use OpenTelemetry with gRPC. So really straightforward. We have this OpenTelemetry plugin builder. We provided the meter provider. We say build and register, and things start working. You just need the additional library dependency, and hopefully it's not too big. I think it's not too big. Right. So the metrics are currently available. They are on the call. We have latency metrics. So you can kind of figure out how long a call is taken. Along with this, as I said earlier, we have attributes such as status. So that also helps you figure out whether there's what the error rate is. You can figure out message size. We have counters for how many RPCs were started. Because as Arvind mentioned earlier, gRPC has streaming support that REST does not. And a quirk of streaming RPCs is since they can be long running streams. So it's possible that you have many streams that are active right now, not ended. And if we don't have these counters for streaming, we won't be able to figure out how many streams right now exist. We've also been adding metrics around load balancing policies, WRR, pick first. We also have XTS client metrics. So if you're running a service mesh or using XTS, these metrics would help you figure out if something goes wrong. Finally, to the demo. Before this, please let me know if you have any questions. For the demo, we've got 2 examples, C++ and Python. Java and Go are still in the works, but C++ and Python are ready to use. We can do this one of 2 ways. We can have me do the demo, or we can do it together. If you have laptops ready, you can try it out yourself, or feel free to go home and try it out if you're feeling a bit tired. It's a long day. I understand. I'll wait for a few seconds. People want to open up the examples. All right. Gonna zoom in a bit. All right. So as I showed earlier, this is a straightforward hello world example. We have taken a dependency on the OTel plugin. We have a simple hello world client that just sends a hello RPC to the server. And the server just responds back with the hello world message. In terms of the OpenTelemetry instrumentation, as I showed earlier, we just create a meter provider, set it up with Prometheus, pass it to gRPC, and let it work. One interesting thing to point out over here is the ability to change views. And this is a thing where on the OpenTelemetry SDK, you can configure your meter provider to change what metrics are finally exported. So gRPC is exporting a set of metrics, right? And let's say we have grpc.client.attempt.duration. We have this is a histogram of how long an RPC takes end to end. This histogram with OpenTelemetry comes with default boundaries, right? So to have 0, 5, 10, 20. And the unit over here is seconds, right? And as I showed earlier with the benchmarks, that's not really helpful because an RPC, a ping pong, would take somewhere in microseconds, right? So we want some newer boundaries. So over here, what I have is I change the boundaries for the histogram. So over here, I want 10 micros, 50 micros, 100 micros, goes all the way to 100 seconds. And that seems more reasonable, gives us more of a picture as to how much time each RPC is taken when put in the right bucket. And then back as normal, we are registering the OpenTelemetry plugin and letting it work. So let me show you how things look like when they run. All right. So I'm just going to run the server. Right, so I was listening. Let me zoom in a bit. All right, so this example continuously sends RPCs to a server. And now, as we've configured Prometheus, what I'm going to do is I'm going to run a local Prometheus collector that's going to scrape the metrics that my server and my client exporting. So I've written a simple config. So I'm asking it to scrape the metrics at port 9464. That's where my server is exporting metrics. And with this, my Prometheus collector is running. So I can go to my browser. And this is a result of one of the scrapes on the local host port that Prometheus is providing. We are using, which port are we using? 7464. That's not it. Nine four six four.
We can see the
So this is the result of the scrape of Prometheus. Now, Prometheus is a pull-based exporter. It would tell OpenTelemetry that give me all the metrics that you have right now. But this is not really useful, right? It's hard to read. So a Prometheus collector usually has a UI with it. So we should be able to look at a Prometheus UI, and we should be able to say, right. So this starts showing you a graph on the metrics. But in my opinion, this is not really that user-friendly, right? What I end up preferring is to use a vendor. And you have many vendors. The one that I'm going to show today is Google Cloud. And forgive me for taking some time. I was setting this up a few hours back, so might not work. Hope it works. So what I've done is I've taken the same OpenTelemetry example, and I've moved it to Google Cloud. I'm using Google Kubernetes Engine as an example over here. So I've created a simple service, the same Hello World service. I've created an image, the same image. It is serving on port 50051. I'm using Traffic Director as a control plane with XTS as a way to do the routing. From an OpenTelemetry perspective, what's interesting over here is this environment variable, OpenTelemetry resource attributes. And what this does for OpenTelemetry is when you're actually recording metrics, it takes this environment variable and uses this to kind of get an understanding of what the environment is. So over here, we've added the pod name, the namespace, the container name. And when we're actually observing the metrics, these would end up as labels on your metrics. Similar on the client side. And Arvind was talking about this earlier, but I didn't use a gRPC route. I'm using an HTTP route for the routing. And to make things simple for me for OpenTelemetry monitoring, what I'm using is Google Cloud's pod monitoring solution. And this is really, instead of having to run my own collector, what I'm going to say is I'm going to ask Google Cloud to create its collector for me. So for example, for my client, I'm just going to create this resource. And this, what this ends up doing is it creates a pod along with your own workloads. And the sole responsibility of this pod is to scrape metrics off of your pods. So you've said that we want to scrape 9464, the port on the client, and it would export these metrics to Google Cloud Monitoring. And how it ends up looking on the dashboard something like this. This is the usual Google Cloud Monitoring dashboard. We have, I'm in Metrics Explorer, which lands us onto this page. We can filter by gRPC metrics. And let's say we're interested in server call duration, how long it takes on the server side. We hit apply and see this heat map. Kind of tells you your 99th percentile, your 95th percentile, 58th percentile. You can also change this view to a mean that is easier to see. And this shows that it's taking 0.0008 seconds, which is what, 800 microseconds. And as I said earlier, you can kind of use dashboards like these to slice and dice based on the labels that are available. So if you just wanted results from a particular job, you could say that you just want results from a job where the value is PSM gRPC server. Right now we just have that, so it shows the exact same value. We could also say that we only want to see data where the status is okay. Do the same thing. Let's see if there's any other value. Looks like you didn't get any transient failures. It's a good thing, I guess. And the same applies for the client side. Any questions as to how this is working? All right. That was a demo. As I said earlier, we are adding many more metrics. We already have a few feature requests, and these feature requests are around the ability to add additional attributes. So as you saw earlier, we have certain attributes that are exported by the system, like job, container name, stuff like that. There are cases where applications want to add their own attributes outside of the resource. That's something that we are considering adding. There's another interesting use case where users want to add attributes based on metadata. So let's say there is an RPC, there's data on the RPC, very RPC specific, that we want to add onto the metrics to get some more observability. This is also something that we're considering. Please stay tuned. Tracing and logging is also coming. The tracing gRFC is in progress. It's very close to getting merged. Logging would also show some progress this year. We've got EG somewhere over here, right over there. So please go to him if you have logging as, if you think logging is coming out too slow, please go to him. That's the end of the presentation. Questions? OpenTelemetry, gRPC, routing.
I have a question. So I saw you using callback API.
Uh-huh.
I saw you're using callback API.
Right.
So that support like a blocking API completion queue as well?
You're talking about C++ callback API, right?
Yes.
So let me show the code for others. I'm sorry, what's the name? What's the name? So Yukon is asking about the C++ callback API. And this is a new callback API, a new API that gRPC C++ came up with. This went public, I think, a couple of years back. So before this, we had something called a completion queue-based API and a sync API. Those are the only two APIs available. But that were kind of complicated to use, because if you wanted to have a performed application. Sync API was slow, but the competition key API was difficult to use. So the callback API is another asynchronous API which kind of models the approach that Stubby, the internal RT system that Google has, and kind of works on the paradigm that when an event happens, certain callbacks are invoked for the user. So there would be something called an event engine that has a certain number of threads and continuously monitors the file descriptors that are registered. And whenever an event happens, let's say you get a new RPC, you would have the callbacks on the API invoked. So for example, if you are writing a server, these are pretty straightforward. I wish I had a streaming example to make it more clear. I don't see it immediately. But the idea is the events would be triggering one of these callbacks.
My question is actually you're going to support the other APIs.
Oh, yes. We are not going to break compatibility, right? They're still going to work as long as gRPC 1.0 still remains. There are talks of having a gRPC 2.0, but I think that's a difficult conversation to be had.
Yes, I think the question is observability supported on all three of those models?
Oh, yes.
You want to probably repeat it?
Just summarizing the question is observability supported on all three of those models? And it sounds like the answer is yes.
Irrespective of what API you use, you'd get observability with the OpenTelemetry plugin.
But if you go to the latest version, right?
Sorry, what?
If you're using the latest gRPC version.
Yes, because OpenTelemetry plugin was developed quite recently. I think it was made available in 161 for C++.
162.
162.
Do you have any interest of backporting to all gRPC versions where people are stuck?
That's a difficult thing because you need to backport the architecture as well. But is there a specific reason you're not able to upgrade?
Right. There are multiple reasons, but
I don't have a good solution for you other than saying if it's a really older version, OpenCensus still works. But for OpenTelemetry support, and we'd be adding newer features as well, tracing and logging, I don't think we'd be backporting them.
okay. Thank you.
I mean, definitely, I think we're interested if there are issues that are within our control, keeping you from upgrading, if we can, work to resolve those.
Any specific problems that we can help with?
Sorry?
Any specific problems that we can help with when it comes to upgrading?
I think
I already implement my way to support also in gRPC C++ 11, very old version. But I'm wondering other people may encounter the same issue.
Other questions?
Would it be accurate to say that most of what you talked about is actually telemetry for a gRPC application, right?
I did speak from a perspective of gRPC,
Okay.
but OpenTelemetry is not gRPC
I know,
specific,
so
and you can use OpenTelemetry to observe any application that you want.
So how easy is it to kind of use this infrastructure to collect like independent data and sort of export it with Prometheus?
Oh,
using
right.
gRPC? Do you have examples for that?
So even if you're not using gRPC,
No, it's not like gRPC application, but like you may want to export it to some remote collector using gRPC.
oh,
Except the data being collected is not a gRPC application. It's some other data basically being collected on the device.
in that case, you don't need to use the gRPC OpenTelemetry plugin, right? So what you would do is you would create a meter provider,
Yeah.
right? And you would create your own instruments from
And
the
then
meter
just do
provider.
that. So this doesn't actually help that in any way, sort of. It's completely a parallel thing. It cannot use much of this, basically.
you can create these instruments, right?
Yeah, it has to be created again, sort of.
Yeah.
Okay.
So, yeah, I mean, you'd be creating your own exporter that is
That's right. Yeah.
using gRPC at
gRPC.
that point.
Okay.
Anybody else?